Hello guys, welcome back to another video. In this video, we will be discussing about how we'll create a node, basically using a structure and a class, how we'll convert an array to a linked list. And in the previous video, I had already discussed with you about what exactly is a linked list and the basic introduction about linked list. In this video, let's start with our first task, that is creating our node basically. So to revise your concepts, so what exactly is a node? As basically this is a node, so it basically contains two blocks. The first block basically contains the data, yes, you are right, and the second one contains the pointer. Again, you are right. Well, what is a pointer? A pointer is something that will hold the address. Okay, that will basically contains the holds the address. It's basically a data type that will hold the address. Okay, so this was about node. Now we need to implement this in our Visual Studio Code. So let's visit our Visual Studio Code. So this is our Visual Studio Code. I will be implementing in C++, and let's see. For Java users, this is similar. This is similar. You can convert the C++ code into your Java code. So how we'll create a node basically is we will first using structure. How we'll create a node is basically, as I already said you, that we need to specify first we need to specify the struct and followed by the name of our, we are basically creating a node, so we will write the name of our structure as node. Inside our structure we will have two fields, that is the data field and basically the pointer. So let's give this pointer as next, because in linked list convention we usually write next as our basically the pointer that will hold the address of the next node. Okay, so now we need to create our constructor. Inside our constructor we will have data and the next. Okay, so this next is not necessary, because initially whenever we create a node, so this next will automatically point to null, so we can write it like this. So this data is basically the data that will be given to us by the user whenever we create our node. So I will tell you how we create a node, the syntax, and the next will always point to null, because for now whenever when we create a single node, it's basically contains the data and its next will always point to null. Now let's let me show you how we'll create a node. So for creating a node, you need to specify first. You need to create, or I already told you that inside our linked list there will always be a header node, and inside our header node, this is how we will create our header node. Suppose this is our header node. So how I had specified the syntax is, this is my pointer, that is the head, and this pointer head is pointing to the new node that I am creating. This is basically a syntax of creating a new node. This is new, basically the new keywords we usually use for dynamically creating our for dynamic memory allocation we use new, and for deallocation of that particular memory we use delete in case of C++. And in case of Java, there is no such concept of this new and delete. There is a garbage collector which will do the same task as of delete. For new, I don't exactly remember what is that. So this is how you will do it in C++. So this is node star head is equal to 12, and now let's see what is there inside our head. So if I will print heads data, and similarly if I point what's there next, because initially our data that is contained inside our head pointer is basically 12, and next is pointing to nothing, so it will print 12 and 0. So let's run, and as you can see we will get 12 and 0. So the data is 12 and the next pointer is basically pointing to nothing, so it's null, that is 0. So this was how we will create our struct using struct. So let's do it in class also. Similar to struct, we need to specify instead of struct keyword we will specify the class, and the rest all is exactly the same. So this is how you will do it in using class. And if I will run this program, you will see that you will get the same output, that is 12 and 0. So now the next, so our first task is completed, so how you create a node, and now our next task is how you will convert an array to a linked list. For converting an array to a linked list, first you need first you will require an array. So let's say I will create a vector, and this vector basically contains 5 elements. So these are random 5 elements that I have taken. Now what I will do, I will create a function and I will give the name of this function to array to linked list. Okay. Now I also need the vector by reference. Always keep this thing in mind that you always pass your vector by reference, because otherwise it will. So basically by reference basically means that you are passing the exact values and not the copy of that particular values. So whatever manipulations that you will do inside this function, that will be reflected in your original data values also, and not inside your copies. Okay. So this is the need to why we use this by reference. So now what I need is, that inside our linked list we always had a header node, and this header node is basically the starting of our linked list. So let's first create our header node. So how you will create our header node, the syntax you know already. So this is the name, basically the header pointer, and new basically for creating the new node, and the suppose data is vec of 0. Vec of 0 basically contains this 12 value. So this is, and also we need to keep the track of our next pointer. So for keeping that, I will create suppose this mover, which is basically initially pointing to this head. So what I meant is basically like this. Let me show you diagrammatically. That will basically help you in understanding. So suppose what I had done over here is that I had created a header node. So this is basically my header node. Okay, and this is basically containing the value 12, and its next is initially null. Next is null because there is no node. I have not created further any node, so this is basically null over here. So and this is my mover, which is basically pointing to my head node. So now what I will do is, so this is what I had done for my first node, for my first element inside my array. Now I had created one node for the, so what is a linked list? A linked list basically collection of nodes. So for the rest of the elements, I will run a loop I less than wait dot size, and what I will do is I plus plus. Now I need to create a new node, so I will create new node suppose temp, and this is the syntax how we will create a node. So this will be vec of I, whatever will be the value, and next what I need to do is I will do movers next is temp, and now I will point this mover to temp, and we need to specify the return type as node star because we need to return our head. So what I meant by that is, let me show you first, then I will explain what I meant by that is array to linked list. I will call my function with the following vector, and so what I had done over here is that this part is already clear to you. For this part, what I had done, I ran a loop from first element to the size of the vector, and what I had done is I have created my node, and suppose for this vec of y, this will contain the value 1. So it will basically create a node. First, it will create a node. The loop is starting from 1, so it will create a node, and it will fill this node with the data value of 4. Okay. Now what it will do, it will move, because initially the mover was pointing over here. Now I need to update my mover also. So what I will do is I will update my mover over here with the, I will move this mover to movers next. Movers next is my 10th. So this is my mover. This was my mover. I'm using M for specifying what for indicating my mover. So the movers next is basically, this is my temp, the new node that I had created. So movers next is temp. As you see, it's temp pointing to temp, holding the address of this fourth data value 4 of this node. And now I will update my mover. So now my mover will point to this temp. Okay. So for similarly for fifth, so for this value, I will again create a node temp, and it will hold now the value of 5, and again the movers next will be the temp, the new node that I had created, and now we need to update our mover again. So this will be my mover now. Okay. So for similarly for 6 and 7, I will again create two nodes. So this is for 6 and this is for 7. So suppose this is 6 and this is 7. So what I have to do, movers next is temp. So this was my temp. So now I'm mover will point to temp, and similarly for this case also. So I hope that you had got the intuition what I had done over here. Now, why I had returned head is because initially my head was pointing to this first value, and for printing all the values of a linked list, I need to keep track of my head. So that's why I had returned my head. So let's write the function for our traversal for printing that basically for printing. So for that I will create a temporary variable because I had already told you that we will never tamper our head node. That will basically mean that we will never perform manipulations directly on our head node. We will create another node like this temporary node, and for basically hold what and whatever is there inside a head, we will pass to this particular temporary variable. And then we will perform manipulations on this temporary node instead of directly manipulating our head node. So what I will do is while temp is not equal to null, what I will do, see out temps data and temp is equal to temps next and see out and build. I will explain you what I done. So let's call our traversal and see what's there in our terminal or output. So as you can see over here is we had got our linked list, that is are 12, 4, 5, 6, and 7. Now let me explain you what I had done over here in the traversal function. In my traversal function, I had done nothing but I had passed my head. So the in my array to linked list function, I had returned my head because I need to keep track of my head pointer. Because while traversing, I should start my traversal from my head node until I reach the null. So that's what I had done over here. My traversal function is I had created a temporary node and point that this is basically holding the head value. And now while temp is not equal to null, it will print the temp data and it will update my temp to the next node. And this will continue until my temp is not equal to null. So let me show you diagrammatically what I meant was that. So suppose this is our linked list which basically contains three nodes, and this is basically pointing to null. So suppose this was 2, this is 3, and this is 4. So what it will do is, so initially what I had done is this is my header node, as you already know. Our first node is always the header node, and what I had done is I created a temporary node which is basically pointing to my head node. So now I will perform manipulations on my temp node. What I have done is while temp is not equal to null, print temp data. So this, let's suppose this is my output. This is my output. Okay. What I have done is while temp is not equal to null, is temp equal to null? No, it is not equal to null. It is containing the value 2, so it will print 2. That's why I done temps data print and update my temp. So it will move this temp to this temps next. Initially temp was here, now it will move this temp to temps next. So now this temp will point to my next node. Okay. Now what it will do, it will check again. While temp is not equal to null, is temp equal to null? No, it is not null. So it will print 3 as the output. So this is basically 3. So it will update the temp. It will thus temp is equal to temps next. So now temp will point to here. It will again print 4 and move temp to next. So now temp is pointing to null. So it has done its work. Now it will print this particular output. So this is exactly the same what it had done in this code. So for this video, we had learned how we'll convert an array to a linked list and how we'll do the traversal also. And also we had seen how we'll create our node using structure and how we'll do the same using class. So for this video, don't follow to like, share, and subscribe. So many more videos are about to come. So please subscribe, share, and like.